Welcome back to the Deep Dive. Today, we are looking at something that honestly sounds like the title of a mystery novel you'd pick up at an airport.
Right.
It's called The Haunted Archive Recovery. And I have to say, looking at the cover art for this source material, I'm already hooked.
It is quite an image.
We have a penguin, I'm guessing it's Tux, the Linux mascot, wearing a full tuxedo, holding a drink, just standing in a glowing server room.
It sets a very specific, almost, relaxed tone. Like, I've got this handled.
It really does. But beneath that cool exterior, we're looking at a scenario that's actually labeled high difficulty.
Yeah.
This is from Season 2, Episode 029 of the material we're covering. And apparently, despite the chill penguin, things have gone very, very wrong on a production server.
That's right. The playful image is hiding a pretty stressful situation. We're stepping into the shoes of a senior architect here.
Okay.
The scenario brief tells us that an automated backup script on a production server, the app server, has failed. And it didn't just fail quietly. It crashed and burned.
I hate when they leave a mess. So what exactly are we walking into? What does the crime scene look like when we log in?
Well, it is a digital crime scene, basically. You have 3 disasters happening at once.
Great.
First, a corrupted archive file, which is terrifying on its own. Second, we have these rogue log files. They're misplaced. They're huge, taking up critical space.
Okay.
And third, and this is my favorite part because of the title, we have a haunted staging directory left behind by a previous administrator.
A haunted directory?
Yeah.
I'm assuming we aren't talking about actual ghosts and, like, flickering lights.
No. But in the Linux world, a directory that acts weird can feel pretty supernatural.
Yeah, it can.
When we say haunted here, we're talking about a permissions nightmare. It's a directory that exists, but you can't really interact with it. It's a ghost in the machine.
Okay, so our mission today.
Yeah.
What are the objectives?
3 main things. First, we have to exorcise the ghosts from that staging area, fix the broken directory so we can actually use it.
Exorcism, step 1. Got it.
Step 2 is a search and rescue. We have to hunt for specific, large log files that are clogging up the system and move them to safety.
And the third?
And third, and this is the trickiest part, the high difficulty part, we have to restore a legacy archive without losing its soul.
Its soul. That's very poetic for a sysadmin task.
It is, but it's accurate. In technical terms, the soul is its security context, its metadata. If you lose that, the data is just a show.
So it might look right, but the system won't recognize it.
Exactly.
I love that. Restoring the soul of the data.
Right.
We're definitely going to unpack that. So the devil's in the details. Let's walk down this haunted hallway. The source points us to Vertent recovery staging. We log in. What do we find?
You find a wall, you log in ready to work, and this directory just locks you out. The problem is twofold. Ownership and permissions.
Okay.
It's currently owned by nobody.nobody.
Nobody.nobody. That sounds incredibly lonely. Is that a real user?
It is. It's a standard system account. It's the system's way of saying this belongs to no one important, but finding a staging directory owned by nobody is, well, it's not a good sign.
And the permission?
The real kicker is the permissions. It's set to 555.
Okay, let's break that down. 555, we usually hear 777 or 755. 555 feels unusual. What does that actually mean?
It's a very peculiar state. In the standard RWX read-write, execute 5 is read, which is 4, plus execute, which is 1.
But it's missing the right permission.
Exactly. It's missing the 2. So you can see what's inside.
I can almost the directory.
Yes. You can look in the window. You can even walk through the door because of the execute bit, so you can CD into it, but you cannot touch anything.
So no creating files, no moving files in.
Nothing. It's a museum exhibit. Look, don't touch.
Which is completely useless for a staging area. It's like a workbench you're not allowed to put tools on.
Perfect analogy.
So how do we break the curse?
We have to assert authority. We're the senior architect. The first step is taking ownership. You run chownroot.root on that directory.
Okay, so we're telling the system, this isn't nobody's land anymore. This belongs to root.
Exactly. The deed is in our name now.
But we still have the 555 permissions.
We do.
Yeah.
And even if you own the file, if the permissions say owner cannot write, the system will stop you.
So what's next?
The next command is trimod 755.
And 755 is the magic number because
The 7 for the owner gives us read, write, and execute. That write permission, that number 2 we were missing, is the game changer.
So now we can actually move files into this folder.
Right. And the 55 for everyone else means they can still look, but they can't mess with our stuff.
So the takeaway here is, before you can do anything else, You have to build yourself a functional workspace.
Absolutely. It's the prerequisite. If you skip this, every command you type after this is just going to throw a permission-denied error in your face.
The bane of my existence.
And there's nothing more frustrating than knowing the right command but having the OS slam the door.
Okay, so the haunted hallway is now a functional workspace. We own it. We can write to it. Let's move on to the hunt.
Right. Objective 2.
The scenario says we have some rogue log files hiding out in varlog. The backup script failed and just spewed data everywhere.
And we're not just looking for any log file. A production server has thousands. The criteria here are very specific.
What are they?
We need files that meet 2 conditions. They have to be strictly larger than 10 megabytes, and they must have been modified within the last 24 hours.
This sounds like a job for the find command.
The Swiss Army knife of Linux. Indispensable.
But the syntax can be tricky. The solution uses any size plus 10M. I want to focus on that little plus sign. How important is that?
Oh, it's crucial. It's the difference between success and failure. If you just typed any size 10M, it would look for files that are exactly 10 megabytes.
Which you'll probably never find.
Almost certainly not. The plus tells the computer, I want anything greater than this size. It's a small character, but it completely changes the logic.
And then we have the time filter. Nanosim time -1. Again, another symbol, the minus sign. This one always trips me up.
It trips everyone up. You have to think about what less time means relative to now.
Right.
In the context of men-time modification time, the minute means less than. So manif1 means less than 1 day ago, essentially younger than 24 hours.
So if I used a +1, I'd be asking for older files.
Exactly. +1 would be files modified more than a day ago. We need the minus sign to catch the fresh evidence from the failed backup.
So plus for size means bigger, for time means newer.
Got it.
Now, the command doesn't just list the files, it has to move them. It uses the exec flag.
Ah, yes. The exec flag is where find goes from being a flashlight to a robotic arm. It lets you run a command on every single file that matches.
And the command is exec mvva vart recovery staging. Those curly braces, I always think of them as a little robotic claw.
That is a perfect way to describe it. That's just a placeholder. It represents whatever file find just discovered.
So find spots a 15 Malinae log file. The claw grabs that file name and drops it right into the MV command.
Instantly. It automates the entire cleanup. You run one line, and it sweeps varlog and puts all the problem files in your safety net.
That is so satisfying.
And that
Is it dangerous?
Extremely. A find is obedient. If you made a typo, say you wrote any size plus 1K instead of plus 10M,
Oh, wow.
you might accidentally move every single log file in the system, and then services start crashing because they can't find their logs.
So the go tip is?
Always run the find command without the exec part first. Just look at the list it generates. If that list looks right, then add the robotic claw.
Measure twice, cut once. Okay, logs are secured. Now we face the boss battle. The resurrection.
This is the core challenge.
We have a file called legacydata.tar. We need to restore it. My first instinct is just tar-x. Simple.
But in this case, simple is dangerous. The requirement isn't just to get the files out. It's to preserve their identity, their soul. We're talking Linux contexts and extended attributes.
So what happens if we lose that metadata? Why can't we just use a standard extract?
Okay, let's think about a Red Hat system. Security is handled by Linux Security Enhanced Linux. Every single file has a label, a context. It's like a security badge.
Right.
So a file that's supposed to live in et cetera has a specific badge. Let's call it et cetera.
Okay, et cetera. It lets it into the et cetera club.
Exactly. Now, if you extract that file with a standard tar command into our temporary folder, the system might slap a generic temporary badge on it.
So you restore the file, the content is correct, you move it back to the et cetera.
And the system treats it like an intruder. Linux looks at the badge, sees it's wrong, and blocks access. The web server can't read its config.
Wow. So it's like showing up to work, you look like you have your name tag, but your security pass doesn't scan, the door won't open.
Precisely. The system assumes it's been tampered with. That's why the source emphasizes the Linux and Gatchers flags.
Let's break down the command then. It's tar Linux Gatchers-nspf. That's a lot of flags.
Each one is vital. Linux tells tar, read the Linux context, store it in the archive, and apply it. Don't guess. Give me the original badge.
And that.
That does the same for extended attributes like access control lists or ACLs. If you had special permissions set up, like Bob can read this but not write, that's stored there. You lose that, Bob might lose access.
No and -f.
Pass is extract. -p is preserve permissions, which handles the basic ownership, and -f just points to the file. But there's one more flag in the solution that's just good hygiene, -c.
Capital C, that's for change directory, right?
Yes. By default, tar just explodes everything into whatever directory you're currently in. The -C VRMP recovery staging tells tar, go to the staging area first, then and only then release the files.
So make sure everything lands exactly where we prepared that space earlier. It connects back to step 1.
Everything is connected. If we hadn't fixed the 575 permissions, this tar command would fail. If we don't use the Linux flag, the restoration succeeds technically, but the system breaks practically.
This really is a high difficulty scenario. It's not enough to know the command. You have to know the whole ecosystem.
You have to think ahead, yeah.
So we've run the command. The archive is unpacked. But you don't just hope it worked. You have to prove it.
Verification, the proof of work.
How do we audit our work? First, we need to check that oversized error.log is actually in the staging area.
A simple else-else handles that. We want to see it there. And the source notes, we should expect it to be 15 megs.
And then the big one, verifying the soul. Checking the SE Linux context. We use a special flag for ILs here, don't we?
We do. The capital Z LSZ. It adds a column to your file listing that shows the security context.
The source gives a very specific string to look for on the restored hostname file, systemu.objectr.exe.s0.
It's a mouthful, but the part that matters most here is the etc.
Mm-hmm.
That tells us the file has kept its identity as an etc configuration file.
So if we saw something like userdempt,
then we know the file has lost its soul. It has a generic temporary badge, and if you tried to copy that back to etc., the system would reject it.
So that etc is the stamp of approval. And finally, we just check that the original log is gone from varlog.
Right. Find used MV, so it should return no such file or directory. That confirms we've cleared the space.
Okay, the ghosts are gone. The data is restored with its soul intact, but we aren't done. There's one final step, cleanup.
The zero trace policy. You always leave a server better than you found it.
So we hit it with the RM-R.
RM-RF, VRMP recovery staging, we nuke the directory, and we also delete the tarball itself with arm-dash.
Why is that so important? I mean, it's just a temp folder.
It's security hygiene. Think about what we just unpacked. That data might contain sensitive configs, passwords, network maps. You can't just leave that sitting around.
You're leaving a back door open?
Exactly. Plus, it's just clutter.
Clean up your toys when you're done playing.
Always.
So this haunted archive recovery is really a story about precision. We use champ and chown, then find with very specific math, and finally tar with these advanced security flags.
It's a perfect example of why knowing the command isn't enough. You have to understand the flags. You know, tar is one of the oldest tools in the Unix world. It's been around since magnetic tape drives.
Yeah, tape archive, that's what it stands for, right?
Exactly. And yet, here we are on modern systems, and this ancient tool has evolved. It now carries complex security metadata, like Linux contexts. It adapts.
That's a really cool thought. It connects the history of computing with modern cybersecurity.
It raises a provocative question for everyone listening, actually. Think about your own backups. You probably have terabytes of data zipped up somewhere.
Sure.
But how many of those backups are actually usable?
What do you mean?
I mean, how many backups exist right now that are useless because they contain the data but not the permissions or the attributes required to actually use it?
That's the terrifying thought. You think you're safe because you have the files, but you actually just have a pile of bricks.
Exactly. If you restore a backup and then have to spend 3 days manually fixing permissions, did you really have a backup? Or did you just have a ghost of your data?
Well, on that spooky note, I think we'll wrap up this deep dive. Next time you see a penguin in a tuxedo, remember, check your permissions and verify your archives.
And check your flags.
Thanks for listening, everyone. We'll catch you on the next deep dive.
Safe coding.